Hi everyone, welcome to the Automated Control Water Management Challenges Solutions presentation. As you know, water is a very valuable resource. We use it for drinking and cooling and industry energy transfer and processing and waste removal. So the management of water is a part of the critical plant maintenance in most factories and most processes. So we're going to talk about some of the challenges we've helped people with to date, give you a bit of an idea of an overview of what's available and the new technology that makes your job a lot easier. So the challenge is level management. So first thing I want to know is how much water do I have. Challenges we've come across recently for those, measuring level in a remote location, so out in the middle of nowhere with no power or infrastructure available. Quite corrosive water, as you can see them from the photos. Some STS stainless steel pressure transmitters getting eaten away. That was about 8 to 12 months worth of submersion in the water. Measuring directly from the surface, but with several pieces of structure and obstructions in the road. And the fourth challenge that we met was trying to measure the level with a large amount of foaming on top of the water. So trying to measure the exact water level without compromising accuracy, but having a foamy substance building up on the top due to agitation. So I'll have a quick yarn about how we dealt with those. We've also got flow. So you want to know how much water is flowing through a pipe. Problem is, first challenge that we met was what happens if the pipe's not full. Most sensing technologies require that the pipe be full, but certainly for accuracy. How do we deal with that if we've only got a partially filled pipe? What do we do if we've got existing infrastructure and we don't really want to cut the pipe? We don't have any access to break into it and put the standard MagFlow solution in. And what do we do if we're in a remote location again? We don't have any infrastructure. We don't have any power. We're a long way from our gear. So also how we dealt with that, and also what happens if we're near a bend in a pipe. A lot of sensing technologies won't allow that to sense accurately. So we've got a solution for that too. Other challenges we've come across are energy transfer solutions. So you've got a clarifier, for example, and you want to power the thing. So you want it to rotate based on power. So some slip rings. Some linear solutions, so scrapers, you may have come across those in settling ponds. As the muck settles to the bottom, you've got the scraper coming along trying to clean it up. How do you power the thing? Obviously, it's because it's moving. And pumps, got to move water. You're generally going to do it with a pump, but you don't want to do it by inducing harmonics, and you don't want to do it inefficiently. So I'll show you a solution for that as well. First cab off the rank is remote location. So I've got a borehole in the middle of nowhere. Got some hydrologists trying to measure the aquifer, trying to figure out what's happening when it rains, what happens when they pump from it, and how quickly it recovers. So what do? You can build power lines and build a whole infrastructure, or you can use a STS battery-powered data logger. So data logger in the top, sensing elements in the bottom, where you can have conductivity, level measurement, and temperature measurement. So the conductivity will tell you, whether it was sort of rainwater or seawater, and the content of the water, and also, of course, the level. So as it rains, it'll fill up, and as you pump from it, it drains away, and gives you a really good indication of what's happening with the groundwater. And as you know, some of the major farming areas are quite critical to rising and falling groundwater levels, so quite critical for those guys. The solution lasted 10 years battery life. That's at 1 reading per hour. Low standby current, so the new data loggers, the new technology in the data loggers allows them to go for a lot longer. They've moved the battery down into the logging part, so you don't have any copper losses in the cable, and it keeps the batteries cooler, which gives them a much longer life expectancy. 500,000 values total per channel, so you end up with 1.5 million values that you can use from. So you can have 1.5 million values of level if you don't want the other three, but you can have 500k worth of values from all three sensors. So the value for the customer was he was able to trend the aquifers on the recovering cycle of the pump and analysis of rain with several locations. He was able to map the whole whole aquifer and manage his pumping systems and the water levels accurately. Second picture tells 1,000 words here. Throw a STS pressure transmitter or any sort of stainless transmitter into the water because the high pH level was just eating away at the stainless steel. It had to be a submersible issue, so we couldn't use a non-contact method due to the infrastructure that was around it. Basically, it was a dam, and there was no structure that could mount over the top of it to use an ultrasonic solution. So what did we come up with? We come up with a chemical resistant submersible transmitter. So it looks like this. If you can see in the end, which you can't, but there's a titanium face on the front of the transmitter, so quite resistant to any sort of chemical attack. Of course, the plastic outside is also very good for chemical attack. It's a very good solution. Was able to prevent maintenance issues from people having to replace them constantly in the amount of time and value they lose for those. And of course, just the straight cost of replacements as well was all saving. Get some reliability out of the system instead. So the next challenge we're talking about for level management is obstructions. So once you decide yes, you can get it up out of the process, and you can measure from the surface. What do you do when there's obstructions in the road? Obviously, there's going to be some other infrastructure there that you're going to mount the thing off. What do you do? So the solution, as you can see from the picture, there was a lot of steel brackets and gating and stuff in the road where they needed to mount this to measure the level. We used the Pulsar Imp. So the Pulsar Imp has got some datum technology. It's very clever. A slide on the next page shows you how it does that, and it was able to ignore all the erroneous structures and just follow the water level based on that, even though it's still getting echoes from the other structure. Second example of that, down a well, we've got ladders and pipes and old sensors in the bottom and float switches and things all over the place. How do we ignore those? Well, the technology, instead of just looking at the first big pulse that comes back as an echo, it looks at a combination of them, and you can go into the software and you can say, all right, well, I want to ignore, for example, the existing transducer was a pretty big signal coming back, and a few other, that's the ladder there, I believe. So, say in the software, you say, I want you to follow this pulse. And as the water level comes up and down, especially as it goes over the top of these, it will follow those, follow the water level as opposed to following those erroneous strains. Quite accurate and works great. The beauty of that for the customer was they were able to do water level management without having to remove all those obstructions out of the way, without having to use a submersible option. Quite a good solution that they couldn't use any other way. And the final challenge we had for level was the foaming, as you can see from the picture. There's an agitator in this tank. As the liquid was agitated, it would foam up across the top. Standard ultrasonic was trying to view that they were using, and it was bouncing off the foam and getting a poor signal, and they had no idea what the level was. So our solution for that, go back to the submersible. The water level is proportional to the pressure at the bottom of the vessel, so we got them an ATM K, which has got a special ceramic face. Here's one we had prepared earlier. It's got a ceramic face at the front, which makes it a lot stronger for cleaning and more hygienic, and had the optional stainless steel braiding on the outside to protect the cable, and it's quite heavy, so the extra weight allowed it to hold in the bottom of the tank, even with the agitator going, without it getting caught up or moving around with the agitator. Quite a good solution for that. Beauty for the customer, they were able to measure exactly what they wanted and never had any failures, and the foam had no effect. And the beauty of that is that now they could keep the level accurate. They never had the foam spewing out the top of the tank like they did in that video, in that picture, sorry. So no waste, no mess, no OH&S issues, far better solution. So level management, there was a few key areas where we were able to help people out, but of course we've got the full range of level measurement management available. We've got guided radar, acoustic switches, capacitance probes, point level detection. So if you just want to know if it's high or not high, got a tilt switch, paddle wheels for especially for grain and that sort of bins, vibrating probes, and of course the standard old float switches. So moving right along, flow. We want to know how much water is going through a pipe, so we know how much of a resource we're using, how fast it's moving, how efficient our pumps are, and several other reasons why we want to know how much water's flowing through a pipe. Problem is, well, the first problem is, what happens if the pipe's not full? What if it's flowing over the top of a hill and it's coming down the other side, and suddenly the pipe's not full anymore? Well, in that case, in this particular situation, they also had the added advantage or added disadvantage that it was H2S rich because it was effluent. So what do we use? We use the Crone tidal flux, specifically designed with a capacitive ring on the inside. I'll show you the picture here. So this white section around the outside is a capacitive ring, tells the sensor what level the water is. So it allows for the water level to flow down, and of course it's got the standard mag flow arrangement to tell us what the velocity of the water is. So with the level and the velocity, you're able to calculate exactly how much flow there is based on that. So quite a unique, quite a clever solution, but it was able to get the customer out of trouble, and they were able to measure something they just could not measure before with any other technology. Next flow challenge that we had is we've got an existing installation. We don't really want to chop the pipes. We don't want to put flanges on. We're trying to run the thing while we're pretty soon after we do the installation. What can we do? We decided, they decided was the best solution would be an insertion. They had a 1/2-inch BSP fitting they were using there for filling and port. So basically screw the Weber flow captor in. Weber flow captor is quite a unique device, works on a calorimetric principle. So as the liquid flows past the front of the sensor, it has a cooling effect, and it uses that cooling effect to measure the velocity of the liquid flowing past, and is able to use that to set off a 4 to 20 milliamp loop, or in this particular situation, they just wanted to know low flow. They were having trouble with it was a cooling water circuit, and they were having pressure, so they'd get a blockage and they'd have pressure, but they wouldn't have any flow, so the cooling wouldn't work, and the device would get hot. So they wanted to measure the flow directly to make sure that there wasn't a blockage, and they were able to do that with the Weber flow captor. Pretty easy to set up. These LEDs on the front will do the set point, flashing set point, and if the flow falls below the set point, it'll give you an output and switch your machine off or give you an alarm. Now, second challenge for an existing installation was they never had a port. They never had any way to access the flow, and they did not want to turn the machine off. A 24-hour installation, did not want to turn the machine off to install any sort of a sensor or whatnot. So a solution for that as well. We said, all right, we've got the clamp-on flow meter. Basically, you zippy tie 2 sensors to the outside of the pipe, tell the smarts what sort of pipe you've just strapped it to. It'll tell you how far apart to mount the sensors, and then it'll start measuring the flow. Very clever, I thought. How it measures the flow is it bounces an ultrasonic wave down through the pipe in one direction, and then bounces it back through the pipe in the other direction. And if the flow is in whichever way the flow is traveling, that will speed up the sound in one direction and slow it down in the other. And that difference is measured quite accurately to tell you exactly what the velocity is. So the faster the water's moving, the bigger the difference. Use that to determine what the flow is in the pipe. And transportable. So cut the zippy ties off, go to the next one, measure the flow in that. A very clever solution, exactly what they needed. They found it in wastewater, large pipes, small pipes, concrete pipes, various different pipes have all the settings inside the software for that, just to punch them in and away you go. So what about if it's a remote location? So we had a battery-powered data logger for remote location for level. we've got a battery-powered flow meter from Crone for very similar function. So how they've managed to do that is they've changed the profile inside the flow meter to a square. So that means you need less power to drive the magnetic flux through the liquid because it's less distance, and that allows it to be still very accurate without having to use a lot of power. So that's essentially how they've managed to get some battery life out of these things. Remote locations, they have set them up with other telemetry systems as well, so they can get real-time feedback from a remote location based on the flow that's in the pipes. So another problem we'll have with flow, pardon me, my bought a flow meter before, and they're all like, we'll have to leave it, five radiuses from a bend or a valve or a pump or anything like that, because the turbulence messes with the accuracy of the flow meter. So mag flows and virtually any other flow technology. Well, we've got a mag flow at the moment. So the application that we had was basically, it was in a really tight situation with a pump, and it was directly after a bend and had a bend directly after it. It was right in between two bends. No way to move it away or move it to a different location. It was just one of those situations where you had no other choice. But luckily, we did have a choice. We had the Waterflux 3000 from Krona. It has a rectangle inner profile again, which reduces which forces the flow through the small orifice, giving a much higher accuracy, meaning that you can have a bend on one side and a bend out the other side without any adverse effect, without affecting the accuracy of the flow meter. Quite clever. Would not have been able to measure the flow with virtually any other technology. Okay, so that's flow. So we've managed to measure the level and managed to measure the flow. Well, how are we going to drive these things? How are we going to get some energy to these moving dynamic installations? So Clarify is the first example we've got. We need to do an energy transfer. Clarify's got some infrastructure in the middle of the dam, which is where the power supply comes from. How are we going to get that out to these motors and whatnot the outside to drive it so it'll spin? First clever, slip rings. Very neat solution this. Not only does it have the slip rings for the power, it's also got slip rings for data, so they can get some information out of the thing and get the functionality you'd expect from a model installation. Also, being a wet area, they've got this red strap around the inside, which was a heating element, so that would keep the temperature inside the slip rings at a nice 21 degrees or a minimum of 21 degrees, so that there would be no moisture build up inside in the slip ring enclosure. Quite a neat solution. Like I said, perfect for the job. Beauty for the customer is low maintenance, lower downtime, and it was actually a solution that they could use. Lots of other options were less than desirable. So that's rotating. What happens if it's in a linear movement, like in these scrapers we were talking about earlier? Well, we've got two options. So settling pond with a scraper, we've got the festoon system. So you can see the flat cable here hanging from the trolleys that are on rollers. So as the scraper moves all the way back here, it compresses. As the scraper moves away from us, it extends and allows the machine to work autonomously. Second option is we've got a powered cable ruler here. So these guys need a fairly substantial size cable, so they went for the motorized version. You can get spring-loaded cables as well, cable rulers for smaller installations or for installations that where the slack is less critical. But certainly either of those solutions are available. Dynamic situations going in single direction linear motion, festoon and or cable reeling options are available. And last but not least, we want to move water. We're going to need a pump. So first thing people say with a pump is, we're going to need some control over the situation. We don't necessarily want to be pumping hard all the time. And what do we do when we've got loads of varying loads? Put the majority of drives on any sort of motor, you're going to end up with harmonic distortion as soon as you're not anywhere near full load. they had two pumps running side by side in this situation, and they were only running at 50% load. And the harmonic distortion they were getting was affecting electronic devices near them. So what was the solution for that? The solution was the Yaskawa U1000 matrix drive. So the Yaskawa has no DC bus, so that gives it the unique ability to have very, very low harmonic distortion compared to anything else in the market, and near unity power factor. It's fully regenerative out of the box. It's very efficient, so there's less heat generated inside it, so the cooling it required less cooling. And the power output and the quality of the power output reduced the maintenance issues with cables and whatnot. It's that good that it won the 2016 Engineers' Choice Award for control engineering. So that's up against some of the smartest pieces of gear kicking around in the industry worldwide, and it was considered the best because of its matrix technology, because it doesn't require the DC bus. The advantages you get are massive advantages. Just as a raw comparison with a 12 pulse and an 18 pulse drive, this is the total harmonic distortion. As you can see, at the higher end, when they're running flat strap, the Yaskawa drive is less than 5% total harmonic distortion. The 12 pulse, the 18 pulse drive, harmonic distortion is quite low at that. But as you can see, you reduce the load, it suddenly gets towards 10, 15%. Harmonic distortion. Now, 18 pulse drive is probably the best on the market. Then you've got a 12 pulse drive, which would be a more standard solution. Is already starting at full speed at over 10% harmonic distortion, heading up towards 25% harmonic distortion at half and quarter loads. So basically, swap a drive, and you reduce the harmonic distortion by up to five times at the lower end of the load capacities. So anywhere you've got varying loads, anywhere that the motors or the pumps are generally underloaded, you can certainly see an advantage for harmonic distortion straight away, and the power savings through power factor and just raw dollars that you save based on using the right technology for the right job. So that's it. That's our automated control water presentation. Thanks for listening. I appreciate your time. If you have any more questions, give us a ring on 02 496 44822. Happy to talk to you. I'm in the office, or you can speak to Chris or Ken, your local sales representatives, as they come around. Thank you very much.